How airplanes fly. Physics has been always considered an essential science for understanding the complexity of the universe. Combined with other fields, it allows a thorough observation of the object under study. This is how fluid mechanics, a branch of physics, together with the application of basic mechanics knowledge allows studying fluids both still and in motion. In other words, it focuses on fluid movement. From here, Bernoulli's theorem is built. The law by which aircrafts fly, also known as the Bernoulli principle after the Swiss scientist Daniel Bernoulli who developed it. Explanation of Bernoulli's principle. Daniel Bernoulli was a Swiss mathematician, statistician, physicist and physician who excelled not only in pure mathematics but also in applied ones, mainly statistics and probability. He made important contributions in hydrodynamics and elasticity. In 1738, he published his work Hydrodynamica, in which he exposed what later was known as the Bernoulli principle, which describes the behavior of a fluid moving along a closed conduit. The Bernoulli equation states that a speed increase on moving air or a flowing fluid is accompanied by a decrease in the pressure of said air or fluid. That is, at higher speed lower pressure, and vice versa, to maintain the same value. One of the most important applications of this principle is the answer to why aircrafts fly as, for this to happen, it is necessary to apply the Bernoulli principle in the wing's design. The first thing we need to know when it comes to explain why planes fly are the forces acting upon them when they are in the air. These forces are 2 in opposite horizontal direction and 2 in vertical opposite direction. Thus, the air resistance is opposed to the impulse of the aircraft, driven forward by the engine action. On the other hand, the aircraft's weight, which pulls it down, is opposed by the lifting force, which keeps the aircraft in the air. This is where the wings and their particular design come into play. Its upper part, called extrados, is curved while the lower part, called intrados, is straight. So, the air that flows over the wing has a longer surface to travel along and gets acceleration due to aerodynamics, running at a higher speed than the air below. In this way, a pressure difference is created between the air above and below the wings, generating a lifting force under them that facilitates the aircraft's suspension in the air. On the other hand, the wing design is rounded at the front and sharpened at the back. This causes that the air current traveling on the upper part at a higher speed, when it encounters the lower current, pushes down. As a result, and according to Newton's third law of motion, which states that each force action has a force reaction of equal intensity acting in the opposite direction, an upward force is generated which helps keep the aircraft in the air.